Hi everyone, I am Stefhanie Tubaces from BSN 1 Batch 1. Today I am going to discuss the three mathematicians. The first one is René Descartes. René Descartes was born on March 31, 1596 and died on February 11, 1650. He was a French-born philosopher, mathematician, and scientist, a native of Kingdom of France. He spent about 20 years of his life in the Dutch Republic after serving a while for the Dutch State Army of Maurice of Nassau, Province of Orange, and stadtholder of the United Provinces. He is the most widely known for contribution to the philosophy, in particular his development of the idea of the dualism of mind and body. And for his famous sayings, I think, therefore, and the last one is I am. However, much of the mathematics we use today owes a great depth to Descartes. Descartes' primary contribution to mathematics was the development of analytic geometry. Throughout the history of mathematics until Descartes, there was always a divide between algebra and geometry. On one hand, we had the symbolic and abstract manipulation of numbers and unknown quantities. And on the other hand, we had the investigation of shapes and solids. Descartes' analytical geometry unified these two fields. He pioneered the idea of representing algebraic forms and equations using the geometric lines and curves on a coordinate plane. His basic ideas are still tough for the high school mathematics today, with the students learning how to graph an equation like y equals 3x plus 5 as a line, or an equation like x equals x2 minus 4 as a parabola. This combination of geometry and algebra was a significant precursor to the later development of calculus, and is such a central idea of modern mathematics that we take it for granted. Descartes' work was so fundamental that we refer to coordinate system he invented, which is the Cartesian plane. And the next one is Johannes Kepler. He was born on December 27, 1571 and died on November 15, 1630. Johannes Kepler is a German astronomer, mathematician, and astrologer. He is the key figure in the 17th century's scientific revolution, best known for his laws of planetary motion. Johannes Kepler was a gifted geometer who applied his mathematical abilities to solidify our understanding of the solar system. Kepler worked closely with the great empirical astronomer Tycho Brahe, who kept some of the most meticulous record of the movements of the planets until that time. Kepler's laws are impressive because they are precise and elegant mathematical description of a physical process. The fact that things in the world, like planets orbiting the sun, follow such laws has been referred to quite elegantly by the 20th century physicist Eugene Wigner as unreasonable effectiveness of mathematics. Kepler's laws are an early example of unreasonable effectiveness. Kepler's laws also set the stage of Newton's development of his laws of motion and especially of his theory of gravity. And then the last one is Blaise Pascal. He was born on June 19, 1623 and died on August 19, 1662. Blaise Pascal was a French mathematician, physicist, inventor, philosopher, writer, and Catholic theologian. He was a child prodigy who was educated by his father, a tax collector. The French mathematician Blaise Pascal contributed to a number of fields of mathematics. Pascal's triangle provides a remarkable elegant way to calculate binomial coefficients, a set of numbers that are important in algebra and elsewhere. He also developed one of the first mechanical calculators in the world, a distant and primitive relative of modern computer. Pascal was also one of the originators of probability theory, coming from his analysis of games of chance. Pascal's work on the basics of probability represented the beginning of our ability to understand chance and risk in a mathematical way.